This is Matthew, and today I thought that we would take a look at this Spartus alarm clock. So I've been using this alarm clock for a little while now. I got it off of eBay for about $5, and it's been awesome. Really, really good alarm clock. It's got these nice, satisfying, clicky buttons, and nice clicky dome type buttons as well for the to actually set the time, and it's really built incredibly well. But well, all except for the battery compartment, the little battery 9-volt guy, that was built horribly. So I actually had just done the first part of this video, and everything kind of went wrong, so I'm kind of redoing it. So I've actually already opened this, and then for the second part of it, I realized that I didn't press record, and then it sucked. And there's lots of reasons why the whole thing sucked. So I'm just starting it over. Maybe this time I won't be so fumbly, since I'll actually know a bit about what to expect. So anyways, let's just go over the clock's operation real quick. Nice, attractive alarm clock. I think, if I'm not mistaken, that this is from the early 80s, late 70s. I don't remember exactly the date on it, but I do remember that it was around there. So it is very, very boastful about the fact that it does have a battery. So if the time goes out, or if the power goes out, you will not miss work the next day, which is awesome. This is like a wood laminate. It's not actual wood. It's just a laminate that is in really good shape, that has a wood texture. The whole thing is in really good shape. The only little downside is that it's got this ding here, but other than that, it's really kind of mint. That and the battery terminal. That one's pretty well dickered. So anyways, Ave vernacular. I've been watching too much Ave. Anyways, let's just go over its operation a little bit. So you can set the time by going to time set here, and just set the time. We'll just set it to 5 a.m. You can see, because there's not the light on. You see how you can see this lip here up at the top? You normally don't see that. I must have pushed it's got a little spacer that's in there back too far. So normally you wouldn't see that. It actually could also have to do with another thing that I did. So, but we'll get to that in a second. Normally you wouldn't see that. There's a red cardboard spacer that goes around this LED display. So you set the time like that. Run is normal operation. There is a bias to keep it in run versus the others. There's a detent there. Very satisfying detent. So we say it's 5:04. I'll switch this. The alarm is off. You can see. I'll program the alarm for 5:05. Let's go back to run and then on. And we should get that nice, satisfying buzz noise. There we go. Just like that. I think that the snooze is 10 minutes. I don't really know. I try not to snooze because I have such a hard time getting up. I've got alarm clocks everywhere in my apartment that all go off and make my life hell at the first part of my day, just so that I wake my ass up. But anyways, so yeah, it works wonderfully. It's been perfectly accurate on on time. Haven't had any issues with the alarm, and it does just have this nice look to it. It is not a radio at all. It also has a battery indicator, which is really nice. And if we look on the back here, it says, low battery indicator flashes when battery is marginal. Indicator is steady on when battery is low. Replace battery immediately to maintain battery backup feature. Something interesting that I don't really know is it says snoozer, which I think is kind of cute, but it says battery tester. And I get the feeling that if your battery is that I get the feeling that holding down this button puts a load on your battery. So we can actually maybe test that with a multimeter. Yeah, let's try that. I don't know if that's going to happen or not, but maybe if we press the battery tester, we'll see a change in resistance. So I've got a little multimeter here. Let's change it to ohms. This particular meter has really low resistance, or at least calibrated resistance leads, so that should work out well. And I've also got some of these little guys just in case we needed to clamp onto something. So there we are. Let's try that. So let's take off this back battery connector. Here you can see the messed up the messed up connector here, where it just pulled right out. So let's go to this. But yeah, I kind of get the feeling that when we press the battery tester feature, that it's going to put a resistive load across it. Right now it's showing 2.2 mega ohms, so that's completely negligible. So if we, yeah, okay, do you see that? So you press the button and then the resistance goes down. Yeah, okay. So it must be putting down, so what is that? That's a drop from 2.2 to like 1.5, something like that. Mega ohms. 1.3. So yeah, so they must be putting a resistor across and then measuring the voltage drop. So if we were to actually press that when the battery was kind of getting lower, we would see the indicator, an indication of what it would be under load. So that's kind of cool. We'll actually make a point to try to find that circuitry involved, just for the fun of it. All right, so let's take a look to see what kind of amperage or how many watts the clock draws. Does it say on the bottom? Probably. So it says at 60 hertz, it's 8 watts. Okay, that's a lot of power. So I have this extension cord that this is plugged into with the split lead here. Let's bring in that clamp meter again, maybe without the leads. And change this just to 2 amps. $16 milliamps. Okay, yeah, so that's not 8 watts at all. So 16 milliamps. This is being filmed I'm in the United States, so we have 120 volts here. At the time this was made, it'd probably show up as 110 volts. Did that say 110? No, 120. Okay. So we'll use my nice vintage V8 VFD display calculator. I'll be doing a video on this as well, but for now, let's just use it to do the math here. Sorry, working around a camera can be kind of fun. So if we say that it was 15 milliamps, so we do 0.015 amps times the voltage, which is 120 volts, then we come out with 1.8 watts. So yeah, that's way less than the 8 watts that they listed. I don't know if the 8 watts is, I don't know. I don't think that there's anything this clock could do to come up with that sort of, yeah, I don't think that this clock will ever come up to use 8 amps of power. I mean, that's 4 times what it's using, you know, and some change. So, but it could be something to do with when the buzzer's running. I'm not sure how hard they drive the buzzer, but if they don't have good current limiting on the buzzer, I know that they can take quite a bit of current. So, anyways, let's take a look. Oh, also, I'm sorry, I don't think I mentioned this. These normally are back under here, these nice little felt washers, and they keep dust from getting inside, but as they're in the different positions, but I forgot to put those back in, and I don't care about redoing a video enough to tear it down, put it back together again, tear it apart again, and then put it back together again before I even actually have my video done. So let's just unplug this and then get right into it. Oh, it's a very stiff extension cord there. Oh, kind of random, but big shout out or thanks to, why can't I remember the last name? Lewis, the guy who does all the iPad MacBook repairs and all of that stuff, for showing me this trick with the magnet on the side of the screwdriver to hold your screws and keep them all together. That's been a real useful thing to learn, to find out. Not sure if he's the one who originally came up with it or not, but either way, I learned it through him. So big thanks to Lewis. All right, get this screw out. All right. So something I noticed before, or when I first got this, is that there's all these marks around where this is and right there. And I'm not sure how that would happen. It seems almost like it was caused by the cord, but there are also some pretty deep gouges back in here, like tooling marks or marks from a tool. So I'm not really sure what all that's about, but it does definitely look like there had been somebody already inside here. I actually think I know why, and I think it has to do with the flex, and I'll show you what I mean by that here in a second. Whoop. So it comes apart in 3 plastic pieces. Let's get this 9-volt battery through here. Also, sorry if the lighting's a little wonky, guys. Am I zoomed in? No, I'm not. I'm just really close to the damn camera. So we can just pull this piece out here. You can see this is just the flex where the flex comes in, and it's got the battery compartment and whatnot, and then this sort of wood-colored plastic. But yeah, you can see definitely no actual wood involved in that. Then on the front here, we've got this piece here, and it's just one piece of translucent red plastic, kind of a filter for the LED, so that it makes it actually already has one on here, you can see, but without it, it would make all of the numbers kind of stand out, or all of the elements stand out, instead of just the one that's turned on. So yeah, so it looks like it's just a single piece of translucent plastic here. Something I thought that was interesting that I think you can probably make out is that this is actually 2 pieces of metal here and here. So it looks like maybe they either updated the design or something, or they had a couple of different designs that maybe, like, I know that I saw, it wasn't the Spartus, like it wasn't this same clock, but it was one that was super similar from Spartus. Like I thought it was the same one, but it had a light sensor. So maybe they used the same plastic piece, and then somewhere in here they would tuck in that light sensor and then have the other piece of metal punched out for that specific model. So, but here's this piece of cardboard that I pushed back too far, and that's why we could see the white there. But we'll take that off to try to keep this as non-messed with as possible. It's already been kind of bent around a little bit, I think, from the last person that was in here. But we can see that we've got the flex coming in through here. This ridiculously long-looking 9-volt cable actually used to be wrapped around this plastic post here, just as a type of strain relief. But I kind of took that off when I was in here a second ago. So this is why I think that somebody was in here. Is if you look at this part where the flex comes in, that's been melted. So I think I'm also kind of thinking that maybe this I'm not sure if it was just that the flex got bent around and then shorted or got yanked out, because I mean some of these marks don't seem like they're from heat. They look like they're just from extreme stress on a cable. But it might be that this got yanked so hard that it shorted together or something like that. Maybe it was a fabric cable. I'm not really sure. But regardless, it got really hot for some reason. I kind of think that this whole transformer has been replaced, actually. The reason why I say that is there's very clearly screws here, screw holes. And I don't know if you'll see that back there, but the transformer doesn't have any screws in it holding it in. It's just kind of floating there willy-nilly. I also kind of think that it's weird that the flex is actually attached to the transformer with just standard wire nuts. That's kind of a weird thing to me. And maybe that is just, I mean, I know it was a different time. You know, sometimes you would find things with wire nuts that were from the factory, but, you know, this just seems kind of an expensive solution. Well, not necessarily. It could have just come stock from the factory like that. But either way, I think that the cable melting the case has something to do with why somebody was in here. And now you can see that this transformer doesn't actually quite fit. I didn't notice that. But maybe that's it. You know, maybe this is stock and a stock transformer, but the screw holes weren't properly sized. I don't know, but either way, it's just kind of an interesting thing about it. But anyways, you've got two boards. You've got your main board here with all the timekeeping circuitry and alarm clock circuitry, and then you've got your board with all of your buttons down here. It says Pringle and then Sigma. So not really familiar with Pringle, familiar with Sigma. It says M9 on there. I don't know why, but all I know is that this is a great board, button board. So you'll see that we've got the buttons, these buttons, with sort of these like living hinges made out of the black plastic body material here. And then these nice clicky dome, like tactile domes. So really nice, robust design. This is going to last for a long time. And the same thing with this middle button. Then we've got two switches. We've got this two-position switch that's for the alarm on and off. And it feels nice and good. You can tell it's got a nice little detent in there, but nothing quite like this one. This one is a huge, chunky switch. And if you actually look on the bottom, and you can't see it from this side because there isn't a cutout there, but both of these switches are placed inside the board with it routed out. And you can see this big chunky switch here actually has a bias for the middle there. You can see that ball detent and wanting it to stay in the middle where run is. Because I think that when you put it on, unlike most modern clocks, I think if you put it on like time set mode, I don't know if it counts up as minutes passed. I kind of think that it just sits there, you know, and I think that that's why you've got time set mode as well. Although it could be so that you just don't, you know, you're not just out of it tired and then pressing the hour and minute buttons. So that could just be it. But either way, really nice, robust design. Then it's just got these cables connecting it over. If we look on the bottom here, you can see we've got a resistor. I haven't looked at the chip yet. I have actually looked at it kind of, I can see it's a Texas Instruments chip. I haven't looked at the data sheet, but my guess is that it probably it probably detects which mode it's in based off of a voltage, like on an analog to digital converter or something for the chip or something like that, some sort of ADC, so that when you go to one of them, you'll have a greater resistance. And I think that that all of the buttons share a common, I think it's a common ground or something along those lines. So, yeah. I would take the board out to look at it a bit closer, but because you can see it's just kind of hinged back in there. But it's glued in the front, so I really can't do that without risking damaging things. And plus it would be tricky getting it out in a hinging sort of way without damaging these living hinges, and I don't want to do that. So let's take this board assembly out, and then we can kind of maybe bend the screen down and take a look on the inside here. So I'll just turn this around, and this part's a little scary because this really locks in there, but it's just kind of, we just got a couple of slots where this board goes down into, and then it's just sort of hinged back here. So I've kind of just been very gently, carefully trying to separate that, but it really doesn't like it. Oh, actually, before that, this is something I noticed that's really interesting. The bevel here, this bevel assembly, it's like it wasn't soldered. It wasn't seated correctly before it got soldered. Like this side's okay, but this side has a pretty major gap there, and it means that it's not completely straight. I might just bend the pins in a bit on that side, or bend them out or something like that, just to try to take up some of that slack so it sits kind of flush, more flush than factory. But let's take this off here. Let me see if I can brighten that up, guys. It's a little hard. I've got some weird lighting at the moment. Oh man, I don't want to break it. There we go. So I'm gonna have to kind of push down, bend. Oh, I have to start a little crunch. I hope that wasn't me cracking the fiberglass, or at least nothing to the point where it's going to damage anything. Okay, so we'll get that out. Also, there's this long, really generous flex, and it was tucked inside, but I didn't do that before I stuck it back together when I started the video back up. So I heard a little tiny, almost crack type noise. Did we crack anything there? No. No. Good. Well, we'll know if I stick it back together and it doesn't work anymore. Okay. So we had the 9-volt battery flex was wrapped around here for some strain relief, but there wasn't any kind of positive strain relief like a zip tie or anything like that. Then we've got a center tap transformer here. That's kind of interesting. I actually already measured the voltage on the last video. As you can see, I did kind of get pretty far into it. But so we've got our center tap, and then we've got 5 volts here, and then 5 volts there. So, and then from blue leg to blue leg, it's a 10 volt thing. So yeah, we've just got a little center tap transformer here. I kind of think that maybe I haven't really gotten very far into looking at the circuitry, but I kind of think that the 10 volts AC might be being used to drive the piezoelectric buzzer in there, just because of the voltage. That, or maybe the chip is a higher voltage than what I realized, but I don't think so. But what I do think is happening is I think that they're using these two. They're using the center tap. It's kind of like in old audio amplifiers where they'll take the center tap and then they'll do half wave rectification on one of the transformer legs so that you pump in 5 volts, and then on the other half of the sine wave the other tap pumps in 5 volts, and then and then the middle leg is connected to the negative as a thing, and that way it's kind of a weird rectification, but you do end up getting unsmooth pulses of 5 volts, and then it goes into a capacitor, like a tank capacitor like this. But yeah, so this is a 5 volts AC, 5 volts AC, and then center tap, and then from the 2 blue wires, it's 10 volts. So let's kind of just really gently, because this isn't socketed in any way, right? Let's just very gently bend this back. There's that. I'll try to get these wires kind of out of the way. Looks like the 9 volt kind of goes up to the upper left-hand corner. And oh yeah, by the way, when we're in here, I'm going to take the opportunity to replace this because it's all screwed up, and I happen to have this one that I made from an old 9 volt battery that's a nice solid construction, so I'll replace it with that. But yeah, so we can look in here. Looks like we've got a Texas Instruments chip, a TMS 3450NL, something like that. And something I noticed right off the bat here is that all of the resistors are gold band resistors, so they're very accurate. That could be just because it's made very well. I mean, I think that you'd have to say that it would be if it has precision type resistors everywhere, but it could just be because of the timing functions and stuff. I don't really see any crystal oscillator in here anywhere, but this might be part of an oscillator circuit there. Is that a capacitor? It kind of looks like a film capacitor. Let's oh yeah, 103J 100. So that's going to be what is that? 1,000 nano something. I'm horrible with the capacitor codes, but yeah. So that's just a capacitor. It's interesting because it doesn't seem to have a kind of oscillator. It really is a one chip show. So if we look at the bottom here, you can see that we've got this LED display, and the pins are all being driven directly from the chip here. Here's where that mains comes in, that 5 and 10 volt AC, and it kind of goes down here. But it is interesting because it looks like it could have gone to the little 8-pin chip here, or 6-pin, I mean, and that wasn't populated for some reason. Maybe that's for another model, something like an op amp or something. I'm not really sure, but I do know that there was that model that had, like, just for instance, the the light sensor to change the brightness of this display as you turn your lights off. But there's some interesting things here for sure. We've got the you've got the mains coming in, and then you've got a set of 3 diodes. And if we look over here too, let's try to get that out of the way. So these two are set in parallel, and this one is set from this leg here. I think, yeah. And oh wait, no, I'm sorry. It goes from the other. Oh no, I'm sorry. It goes through so it goes through this leg here. So this is this far leg. It comes down here, and then we've got the capacity for multiple diodes to rectify here, but we only have the one. But then it goes and it follows down, and it goes straight through the chip. So, and that's unsmoothed. That's a really weird thing too, is that particular output. Oh no, actually, I'm sorry, I'm wrong. It is going into this capacitor. Yeah, so it's rectifying it here, going into this tank capacitor. Let me put this back on autofocus, and then going out to the chip. So that's why we've got our nice steady. Looks like it'll be a 5 volts. Is that right? Yeah, this would be 5 volts. But then we also have this other diode going, which is AC 5 volts coming through. And then this goes to this leg of the chip and goes back down around and then through down over to here. And over here, we have another little diode. And I'm not sure if that's a Zener diode or probably not. It's probably just a little normal diode, little normal glass diode. And that seems to all go over to like where the battery is, to the negative of the battery, and then also the positive of the battery kind of loops around and then comes back over here, and then goes through something like a resistive divider into the chip, probably to keep its timing functions going. But yeah, it looks like the display itself though is actually being driven straight from the chip. Do we have power going straight to it off outside of the chip? I think that we've got negative over here is what it is. We've got our negative rails over here, and then we just have a couple things joined together. And this is what keeps the so it must be driving the positive through these legs over to the negative over here, something along those lines. Then we've got all of our buttons here. These, by and large, go in directly into the chip, but then we also do have, so we've got this blue wire, looks like it is connected to ground. Or no, actually, that's positive. Yeah. Looks like it's connected to ground, and then I bet you that the black wire here is, oh no, that's just connected straight to the chip. Yeah, so it looks like we've got ground, and then so we're probably just pulling down the chip low. It is interesting the number of support components here that, like, I mean, I think we have a resistive divider here. I don't know if this is just a little Schottky, not a Schottky, I'm sorry, a Zener diode. It's probably a resistive divider and then a Zener diode just to keep a nice stable 5 volts to this as the voltage waivers. That's almost certainly what that is, because you'd want stable voltage for this chip to actually make it function. I'll pause the video real quick and then go print out the data sheet on this chip. Be right back. I tell you what, this is a data sheet from a time when they cared about actually giving you every little detail. But I suppose that you can't really assume less from Texas Instruments. But definitely a heck of a good data sheet. So they explain all of the different. So basically, first off, all of those transistors that we, or not transistors, resistors that we see on here are definitely to set parameters. It's an incredibly customizable chipset. For instance, there's a talk up here about the. Oh no, actually, it's on another page. I think it's maybe this one, but it talks about choosing your values of resistors to dictate how long your snooze is, for instance. So, like in theory, we could just replace some resistors and then get a longer or shorter snooze if we wanted. Pretty awesome. But yeah, they've even got in this sheet, they've even got power supply fail voltage characteristics, so like when a clock is going to end up resetting itself based off of a lack of power. That kind of stuff you would expect. But they've even got down to how much current is going to be drawn based on the time of the day. And the reason why that is different is, but if you look at this is cool. They've got the segment output currents based on the time. Reason being because it's going to have more segments on, and therefore you're going to have a greater current draw. I mean, they've got some of the stuff they've got in here as far as the actual characteristics is really impressive. But what we're really after is this sheet here, and you can see that it's got where it's driving with the top pins here. It's driving the LED panel. You can see that you've got your 50, 60 hertz coming in, and this is our center tap transformer there. So you can see we're driving our chip through a resistor on a negative voltage, actually, interestingly enough. Negative from the display, at least. And then we are driving the display itself at a higher voltage. I got that wrong. We're driving it at a higher voltage, and then since this is a lower voltage, this is going to act as the ground for this, even though the VSS and other voltage pins are actually less in this. You actually, where it says 50, 60 hertz in, you set what frequency it's running at based off of a resistor value. And then you've got your buttons here, and then they're connected to ground. So that was right on that. And then you've got your alarm outs, and yeah. So basically that's kind of just the way that the segments are driven. Here's the actual pin assignment, and I've never really made a clock before, but you can buy these chips still, and you can buy these chips for a really reasonable price. Like by that I mean like 70 cents kind of thing. Sorry, I just said that it's going to record on a new file because we reached the 40-minute mark. Pretty long file. But so you can still buy these chips, and they don't really take much to run. So I might actually use this chip in a project, like a clock project, and maybe see what I can do with that. But but it's definitely an all-in-one kind of solution. Something I didn't check to see is if it has a built-in oscillator. I don't see. Do we see any clock in? No, just hertz select. So that's about it. So yeah, so this is this should have its own built-in resonator. So that is a very simple project chip if you wanted to build a clock. But so yeah. Anything else to say about it? Oh, the the piezoelectric buzzers down here, was it being driven from, it just says alarm out on this sheet, the data sheet for the chip. What's driving it? So first off, where's it's the red and black wire going to there. So we've got oh yeah, it's going straight to the chip, right, with alarm out. That is, so yeah, so I mean, even driving the piezoelectric buzzer is in this single chip, so that is pretty impressive from the time frame and stuff. So, all right, well, awesome. Well then, I guess all that's really left is to replace this, and then I'm calling it good. I'll just do that and then cut to everything reassembled. So I put this thing back together. Things are looking good. I replaced that bad flex here that was so crappy with a much better one. If you ever make home-make ones based off of like using the dead batteries, dead 9-volt batteries, this top part, you always get a nice, really strong plastic one versus the really crappy ones that come in most of these electronics, where they've got the cardboard, and they just last a way longer time. So, but yeah, so I hope that you guys enjoyed this video. Hope maybe you learned a couple of things, maybe not. Really, it was just a cool look at some cool old retro tech, and I'll see you in my next video.